Good day, folks. Welcome to my YouTube channel. This is the grade 12 electric circuit question. It's a national paper, November 2023. All right, let's cut the chase. Now it says a circuit diagram below shows a battery with an EMF of 12 volts and an internal resistance of 0.5 connected to 3 resistors, a light bulb, a switch, and an ammeter and connecting wires. An ammeter and connecting wires have a negligible resistance. Let's look at our circuit. The current will come from this side from the battery, and then it passes the internal resistance, and then it passes the ammeter there, which is this ammeter reads the total current, and then goes there, and it goes there, still a total current. When it gets there, there's a split. There's a current that goes that way, and there's another split that goes that way, right? So that one, there's a split as well there. There's a split as well there, and there's a split there, and then it combines and become the total current as well. If we look at this circuit, we have a light bulb there. So in this light bulb here is parallel. It is in a parallel connection with this, but not the light bulb is parallel to this one. So the total of these resistors, which is these ones that are parallel, plus this light bulb are parallel to that one. I hope that makes sense. All right. So these ones are parallel in this parallel section that is parallel to this R3. I hope that makes sense. Okay. Now let's answer the question. I'm going to start with 8.2. It says switch S is initially closed, which is this one is closed. So all these resistors are effective. Now it says in 8.2, calculate the total external resistance of the circuit. The total external resistance of the circuit, that means I have to calculate this parallel and add this one because they are both parallel. They are both series to each other. This one is series to this one, and then the total of these two is parallel to that one. So I'm going to first calculate this parallel and add to this one. So what I'm going to do, this is 8.2.1. I'm calculating the external resistance. So what I'm going to do, I'm going to say R parallel, which is R1 times R2 over R1 plus R2, which I'm focusing to these ones. So it's going to be 10 times 10 divided by 10 plus 10, which is going to be what? 5 ohms if you punch that in the calculator. So this will be my R series. What is my R series? Is this one plus this one. So my R series is made up of the resistance of the light bulb plus the R parallel, which is this parallel section, right? Then it's going to be 10, this one plus the R parallel, which is the 5 that I just got, is going to be 15 ohms, right? And then now I'm going to make the parallel of this with this one, right? So I'm going to say R parallel, which is the R series, which is the series is these ones, R series times the R3, which is the R3 is that, which is the R series plus the R3, which is going to be, the R series is 15 times 15 divided by 15 plus 15, which is going to be 0.75 ohms. So that's my R parallel. So my R parallel is equal to my R external, which is 0.75 ohms. So I answered that question. Now calculate the reading on an ammeter. The reading on an ammeter, which is this one, It's the total current. So the total current, how are we going to calculate it? It's 8.2.2. I'll use the EMF I. I'm sure there are many other ways to do that. So I have an EMF, we're told it's 12, and an internal resistance it's 0.5. So it's 12 equal, we want that current, it's the total. The external, we just calculated, it's 0.75, and an internal is 0.5. So that will be 8. So your I is going to be 12 divided by 8, which is going to be 1.5 amperes. So the total current is 1.5. Now let's go to 8.2.3, calculate the power dissipated in R3. So we want the rate in which the energy was transferred here, right? So what do we have here? We only have the resistance there. And what else do we know? Do we know that this total current that comes here, which is 1.5, it splits equally here. The 1.5 it splits equal is going to be 0.75A, and here it's going to be 0.75A. Why? Because the resistance here, the total here, we just calculated here, it's 0.75. Sorry, no, it's not 0.75. We calculated the current here, we call it a series, which is 15. This is 15 and this is 15 here. So that means it splits equally. So what I'm going to do, I'm going to calculate this current. I'm not going to assume it's 0.5. I'm going to show it by calculation, which is 8.2.3. I'll say the current in R3, which is R3 is this resistor, is this. R3 is this one. So I'm going to say equal to, what is the resistance here? It's 15 and it's 15 here. So I'm going to say 15 divided by 15 plus 15 times by the total current, which is 1.5, which is, this is going to be a half times 1.5, which is going to be 0.75 amperes. So the current that passes in R3, I've proven that is 0.75, right? So what I'm going to do with the 0.75, I'm going to calculate the power, which is power is equal to I squared times R, which is the I is 0.75 square times R, which is the R. The resistance here is 15. So it's 15. So the answer there, when I punch that in the calculator, it will be 8.44 watts. That's the power there, right? Let's go to another question. It says in 8.3, the switch is now open, which is when this switch is open, the effective resistance that will be here is this one. So the circuit becomes series now. If it becomes series, what do I mean? There's this 10 plus this 5. So it becomes 15. The external resistance, remember the external resistance, it was 0.75, right? It was 0.75. Now it becomes what? 15. It becomes 15 because it's this 5 plus this 10. So the total resistance increases. Okay, let's answer the question. If the resistance of the light bulb remains constant, which is this resistance is not going to change in this light bulb, it's going to remain as 10. Now it says if the resistance of the light bulb remains constant, how will the brightness of the bulb be affected? Choose increase or decrease or remain the same. All right, so my answer here, I will take it as if the total resistance here has increased from 0.75 ohms to 10 ohms, this simply means that the V external here, what's going to happen to the V external, right? So The answer here is going to be increase. I'll explain why. The answer here is increase. Now explaining that, so it's 8.3.2, which is this one. Explain the answer. So the answer there, you say in words, not like this: the total resistance of the circuit increases. So if the total resistance of the circuit increases, what's going to happen to the total current of the circuit? That means it will decrease because they're inversely proportional. And that changes the V internal. The V internal, what's going to happen to the V internal? The V internal, since the current decreases, it will decrease as well. So that makes the V external to increase. Because the R external increase, the V external will increase as well because they're directly proportional. So if that increases, that means the voltage here will increase. So that means the voltage that is used by this bulb will increase. So if the voltage increases, that means the brightness will increase. So now we'll say the voltage in the light bulb increases. That causes that the power of the light bulb to increase. That makes the bulb to be brighter. Why? From this formula that says power is equal to V squared over R, the voltage that is utilized by that bulb increased. That causes the power to increase because the resistance of that bulb, we're told, it remains what? Constant. So the power, the power and the voltage, they're directly proportional. Since it's increasing, the power will increase, and the power is directly proportional to brightness or intensity. Right? I hope I make sense by that. Cheers, bye.